report this to Zipper multiple times, but I really don't know how to fix this. Their engineer also don't know how to fix this. They
Okay.
think it's a software update issue, but we can't really
So-
update our software.
So
So
now
if
what?
something like this happen, basically it's already stopped recording, so you can raise it up a little bit, and then you actually needs to do a hard.
A hard reset?
Yeah. So what happened is that it stop in this that loop. It can't save the data,
Okay.
and it will try to save the data, but it can't do it. It would show up this
Okay.
transfer needs to retry again. I was thinking the computer is maybe just completely full of temporary saving drive, but that's not the case. If you just take a look at the actual computer setting itself,
This PC. Yeah.
it has more than enough space.
Yeah.
So I have no idea, and I don't have I don't have a way to to solve it. The only way is a hard reset. So basically, just reset the software again. You do need to recalibrate every single time if this happen. I also found that if you calibrate it oftenly, maybe 2 or 3 sample, you just recalibrate, or you can do 1 sample indented 3 times, recalibrate, and move on to the next sample. This would reduce the chance of that thing happens, but it still happen from time to time. It pop up. You just have to retry it.
So since I'm not submerging it, I just calibrate it, right?
Yeah, calibrate. Let's do the difficult higher before you can do the rotating of your leg. Yeah. And then find the next hydrogel you want to work with. Maybe easier if you send up, so you can actually see from the top if it's rightly centered it, and you can, once you feel like it is, like the probe is going to hit the hydrogel, you can slowly lower it down. If you feel like this is too slow, you can unlock the lever, but again, with the lever unlock, and this is getting
It'll fall.
light, so it can potentially fall. So try to avoid exerting too much force onto the whole housing. It's a bit janky. Yeah.
But can I move the plate now?
Yes. You can go a little bit lower, just right before it gets into contact.
I think it's like in contact.
No, I don't think they are they. We will see when we restart the software. If you saw a negative force, that means they are in contact. Okay, maybe go a little bit lower.
A little lower?
Yeah, so this is where you have to monitor the force loading. See if you can keep this force maybe to negative 100. Oh. So keep going down a little bit. This is where you have to rely on sort of a feeling. Oh, now it's in full contact with it. So now it shows the force to be 800, 900. So that's the equivalent of actually hitting the hydrogel, so it starts to release the energy. Okay, almost. So now it's, yes, oh. So negative 200. Negative 400, so you're going a little bit too much up.
Oh.
So you want to go back down a little bit. Oh, ooh. Okay, just let it be, let it stabilize. So right now you're looking at roughly like a negative 50 something. I think for today's training purposes, as long as you know where you're trying to hit, we don't have to spend too much time of adjusting this exact force. Again, the format of your sample, because your hydrogel is too tiny, so that it really, you don't really have that much of a wiggle room. Next time, if you go with 96 well plate, this process is much easier
Okay.
to achieve. To basically, you have a larger surface that can capture your probe, so it's much easier to adjust to the final value of -100. Again, this force, you kind of have to play with it to know where to start, but it's always a good idea to hold the starting force as a constant so that you can compare it between different hydrogen.
Mhm.
So,
Oh,
Why
nice.
do you pick -100?
so because I do give it a little bit distance, allow the probe to go down. Again, it's this nail versus hammer
Yeah.
that you can't just have the hammer already onto the nail to push it down. You generally want to have a different, a little bit space, a movement space, so that when the probe hitting the gel, it's like push on it.
It's perfect now. It's like right at 100.
Yeah.
Okay.
So you can go ahead and hit stop. So you want to change the name to whatever you want. Otherwise, it will try to rewrite the previous file. It will give you a warning. And yeah, just hit start. So you see, if you find the force correctly, it actually able to absorb as much as force as possible. Previously, this is like roughly around, the first test is around 1,100 something, and then the second test is much lower because there's too many empty space in between. When you find this constant of starting force, you eventually get a more consistent, what we call the transient force. That is essentially the force associated with a time. So this is essentially a function of time. So you can see the curve going down this far is as straight as possible. So it's, again, it's much easier to show you with the MATLAB data.
Yeah.
With the MATLAB analysis, when you see how the curve fit, you, based on what I saw, you probably will get a pretty high R-square. Yeah. So let's try the next.
Oh.
The location and the name. Once you set it once and it's successful to run the file, it will save everything under the designated location that you want it to be. So this will be in the tier file. So just save here. So now it's everything. So this is wherever file name you want to type it in. I don't know what hydrogel is
You
this.
can just
So
put the date.
date, that will be 2024 7/12. 7/12. Test 1. So let me reset the pro a little bit. So basically just gently pull it up. I do set the file to allow the machine to pull itself up, but it doesn't move too far away. Basically, I want to have a gentle release. For my hydrogel, it's also very sticky to the point that if you draw it too fast, the counter force will actually yank the whole pro down to the point that it will stop working. It's again another sort of major issue I encounter with my work. It's showing negative force. Let's try this again. So I don't think I should find the gel location this time. So I think it's much easier to work with 96 rotate because once you get in contact, you can clearly tell. This is a bit more tricky. So this will be a equivalent of incorrect indentation. Once you run the code on this, you will see how bad it is. So you can see now, because I have the equation loading that was able to find the location of the indent, so it's still able to do the indentation and it will generate that curve, but this curve won't be as strong as the one that it had before. That's because a lot of force that it applying to didn't even get catch by the hydrogel itself. So you are basically punching air, and that the air doesn't conserve the energy you want to record. Essentially, this entire process is you give your hydrogel a certain amount of energy. That certain amount is provided by how long the distance is, and then once you provide that kinetic energy, you want to see how slow or how fast it releases this energy. So from that's you will learn its physical property from either the spring, that will be your sort of a steady state moduli, and you will also learn the viscosity. That's where the viscous part, the slow deformation part, comes to work, and that's sort of the gist of it.
Okay.
I'm going to start the start software, and I may need a little bit more space. So I'm going to very slowly, gently lower the knob. So basically lower it down. Pay attention to the actual force value here. Ideally, you want to see a larger negative force start to show up here. That means the hydrogel is making contact with the probe. Because the hydrogel contains water, it is the water tension that pulling the probe down. So from that point, you know the probe is actually in contact with the hydrogel. Okay. Or it's already in contact with. Go up. So this is now in hard contact. It's not pulling it. It's already indented. So this is the reason why. Oh, I see the negative value there. Okay. So this is another reason if you work with a hydrogel or bigger, like in a 96 well plate, it's easier to see. Is this positive? Okay. Let me move up a little bit. Okay, I think this is where I'll just pause. Maybe go up a little bit. For my format, I generally start with a negative 100, so that I know I'm giving it enough space for it to have this movement. It's like having a hammer striking a nail. You don't press the hammer onto it. You give it a little bit distance, and then the force hit on it. A little bit more up. Okay. This is something that you may have to do some additional, just play with it to do the testing. So what I'm going to do now is just go with it, see how does it work. Okay, now it starts to indent it. So this is the force of indentation. So it goes further and further. When it stops, you will see a classical trend going down. So this is equivalent of after it absorbs the force, absorbs the energy, the hydrogel start to deform, and with this deform, the energy, the kinetic energy that it absorbs start to get released out. Think of a spring. When you press it down, the spring gets tight. It also gets energy, but when you stop applying this force, instead of acting like a spring, because this is not hard material, it will slowly go back up, but it will also slowly degrade its original structure. So your energy release coming into two forms. One is the spring, the other one is dashpot. And that's exactly how the equation was constructed. Once you have this file, and so you basically say you want to save it as, let's see, let's just create another file. Just create one here. I hope I save the other one. This is actually saving under my file. No. So that's today's date. Did it save under this one? Let me see. Do you want me to slow down a little bit?
No, you're good.
Any question?
If I have questions, I'll ask.
Yeah.
You're good.
So this is sort of how the principle of how that works.
Mhm.
So you can also see that we always use piezo as an actuator. You could potentially have this changed. And there's actually another transducer, but I never use a transducer because it's a much larger range of force to be recorded. I always use pixel. So I recommend that you start with pixel until to the point that you don't get a good data, then you maybe switch to the transducer to see what happened there. So let's just say we go through the entire indentation protocol. We stop, we pause the bioscan, we install the probe, and now everything is done and ready. So the next thing to do is calibration. Again, based on the sample that you have, we are not doing anything submerged. If you are trying to do hydrogel submerged simply because your hydrogel, you have too many samples, and when you put the sample here and it's waiting too long, so the hydrogel start losing moisture and it changes physical property. If that's the case, you may want to submerge your sample. That means when you do the calibration, you have to do the calibration submerged. It will detect and record buoyancy, especially when it had given a downward thrust. That means all the positive force is actually going downwards, or the negative force going upwards. Sorry, I'm so sorry. The other way around. All the positive force is actually going upwards, or the negative force is pulling downwards. When the probe surface start get in contact with the hydrogel, the first force it experiences is actually pulling, it's not pushing up. So before that, let's just go have a little calibration. You can generally just go with calibration and go to calibrate sensor.
Okay.
Just let it run as program.
It's slow.
So basically it's reset everything. I'm not 100% sure what are the internal mechanism, but it will just do this going down, going back. And then it will generate a report telling you what the magnitude of the noise is over the, so you want to see, show me detail. And you can see that as it trying to calibrate itself, it becomes smaller and smaller, the percentage of the error. If you hit close, it will generate a report to show you. What's it pop up? So this is actually not good enough. What happened is that as it goes, my understanding as it goes further, either going down or going up, the arrow force is getting too big. You want to limit the arrow of this between positive 20 to negative 20. It used to be positive 10 to negative 10, but I just don't think it can go back to that prime time due to its age. So if you see something like this, I would just try to recalibrate it again. So there's another way that you can do calibration is click on instrument setting and then go to low cell sensor. Another to do is you want to update the sensor tier. I find that this sometimes help me a lot by just asking to reload certain forces. And then after that, do another calibration. What happens is that every time when they do a calibrated sensor, it will update the sensor tier. But you can always tier it first and then do a calibration to save you a little bit more time. So I'm going to just go with the calibrated sensor again.
How do you know when it's done tearing?
It will so it will basically run, and then your mouse, the mouse symbol would turn back to
Okay.
the cursor instead of the glass, the hourglass symbol, and you will able to see the number changes. More often, you may have to do 2 to 3 calibration to get it into a correct range. All the calibration file will actually get saved. So in this case, I'm just going to just close it to see what the final report is. So
Oh,
yeah, this is
it's better.
good enough. So generally it's between positive 20 to negative 20. And the force that you're going to indent generally, like from my understanding with my hydrogel, the minimum force is roughly around 100. So this is definitely within the range, but it is kind of large in terms of the error range. So that's just the system flaw of this particular set. So now with that, I think we can go start. I will pause just in case I accidentally touch anything. I'm going to just start with the one next to you. It's really, really sensitive to the point that if you just,
Yeah.
it actually will record the disturbance. That's one of another reason you should only operate on this table until you get to the point that you need to operate on this. Minimize anything that can generate any kind of movement. If your cell phone kind of vibrates, it actually will record it. It's fine. Another thing is that you do have to pay attention to the other room that, sorry.
Oh, no, you're fine.
If someone is running the
Flow?
the flow actually comes with a motor, and the motor vibrates. This actually will pick it up.
Oh, wow. Interesting.
Also, is that it will pick up the vibration generated by closing and opening the door.
Or if somebody's using that back there, maybe moving around.
I'm not sure about the microtome.
Yeah, or that's a embedder, tissue embedder.
Tissue, I don't know if it actually generates any kind of vibration, so I don't think that would be too much of an issue.
Okay.
In the past, this used to be on the same table with that, and the fan of this computer will actually get picked up by that, and also able to check what the noise is. So that will actually get to the calibration part of it. So basically, it says start off from the beginning. Basically, it just start off from the computer. If you have already started up and you want to change the prototype, for example, change a different prototype after you're done with this, it's highly recommend you pause the software first. So that means it doesn't record any kind of force. It recorded as a so the voltage value, and that voltage value is generate what they call a piezoelectrode. That means the striking any kind of motion from the sensor will actually strike a crystal inside the housing, and the crystal inside the housing will actually generate electric current. So that's how the force get converted into some sort of electronic signal. Let me just move this up. Yeah, it's definitely able to indent it, even though it's kind of low. Two locking mechanism. One is with a sort of a
Lever?
jamming lever, which jams the actual rail behind it. I don't know if you can see it from this side. And because we have been using this quite a lot, and it kind of get like just wear and tear. So what happened is that I would have my hand try to hold on it, because without that, it actually just drop.
Okay.
So make sure you actually get really careful with it.
So you gotta hold it.
You kind of have to hold it a little bit. Move it a little more. So you kind of have to reach down, try to get it. Again, my hand is, compared to this, is too big. What you can see here is actually a thread that you allow you to screw it in, but when you try to screw onto it, just follow the right hand rules. But don't use too much force, otherwise you might sort of damage the actual housing itself, because the torque you exert onto it. So just be gentle. You don't have to screw it really tight, like a finger tie is more than enough. You don't want to install the probe before you turn on the program. Since the computer is off, we can just go with it. So the probe is really tiny. Do we have a clean wipe somewhere?
Yeah,